Welcome to all to the last webinar of the final webinar series of Sender Project. In the previous ones, we have depicted outcomes and lessons learned from Sender pilots in Austria, Weiss, in Finland, Tampere and Espoo, and Spain, Valencia. Demand response experience, co-creation and consumer engagement and technology implementation aspects developed and deployed in Sender projects such as smart grids, interoperability, market innovation, and IT solutions, but also data management and security. And today we will focus on policy and recommendations. And regulation. Work and outcomes of the Sender project, together with business models and exploitation results. I'm sorry, my throat. Okay, we'll have also some Q&A section. So if you have any questions after each of the two different parts that we are going to explain today, okay, you will have time to do it. Or if you wish, you can also write your questions through the conversation, through the chat. Okay. So first, the regulation is very wide, the range of it in the energy regulation, market regulation. It's very wide. We have focused in Sender in the flexibility market, the demand response regulation, goals and policies, but also in some other aspects that can maybe impact, even though, for example, sector coupling or something about electricity, that can impact the Sender project. As said, there are like a lot of documents of different directives, communications from the European Commission. Then the first step is to limit a bit to the framework of what we are going to analyze, what is important to us, it is impacting the most, depending on the subject and the topic of the project. This applies to the European regulation, but also for the national regulation analysis that were done more in depth, depending on the use cases analysis in Austria, Spain, and Finland. So first, there was established a two-step methodology, but before to clarify the framework a bit, what we wanted to have clear is if the energy policy goals in these three main aspects, such as flexibility and market and demand response, were already reflected in the European legislation, energy legislation. If they are, okay, where, which, okay. That was the first step. And then in the two main analysis, one from the top to the bottom, from the European legislation, and then we went through the national analysis in these three countries. The first step was the high-level analysis at the European level. Okay, and here there was like a check period of checking if the GDPR and the use cases were compliant with national regulations and also European regulation, of course, GDPR also about privacy and security regulation. This provided like two outcomes, a more efficient co-creation process that we have already discussed and presented in webinar 2. But also it was a first step to ensure the compliance of the use cases of Sender with the regulation. Okay, the second step, we have a more in-depth analysis of the use cases as the co-creation process advanced. There were provided some questionnaires, and from the demo sites, the partners, they choose different national advisors. So they help us with the analysis of the national regulation regarding that affected and impacted the different use cases to identify legal obstacles and barriers. So we could have the outcome of, okay, here we have a gap, here we have the different obstacles and barriers, and the gap between the European legislation and national legislation, I mean the transposition maybe has been done in some parts, in another ones not yet, or in another countries are in something in between, we can say. So then we could provide some outcomes as recommendations to the national regulation authorities in these countries. Said that, I would like to let the floor to my colleague Ahmed Edar from Smart Innovation Norway, which will explain the results of Sender about business models and markets. Later on, we'll have the part of Sender's regulatory and market recommendations that will be explained by Michael Schmidt-Haller. And here, maybe I can let you the opening remarks of overall business model approach to Ahmed, so then you can continue with the business models section. Okay, so go ahead.
Okay. Thank you for the introduction, Estibalis. So this was the overall approach. As you see here in the middle, there's this the task related to the business model development, and you can see kind of what is being fed into this, considering the regulations as kind of defining what works and what is allowed and what is not allowed. But this was kind of the relation between the different tasks. There's also things that has feedback. So if you see on the left-hand side, work package 7, so focusing more on the demonstration activities, and the output from the business model development part also informed the exploitation of the results, like the roadmaps, the plans, as well as the IPR management for the different, the intellectual property aspect for the different partners. So that was just an overview of the kind of the connection between the different parts, and my colleague Michael will talk more about the policy aspect and recommendations. But first, let's take a look at just quick refresher. What is Sender, in case you haven't heard about it before? So the project is pretty much, I can summarize it in 3 words. It's trying to deliver demand response and doing so through automated control of household aspects, or thinking residential household, and it was also trying to keep the convenience and the comfort of the user. The solutions were developed were co-created with feedback and input from actual residential households, and was tested in 236 households, like the different households across the 3 demonstration sites. And I'll get back to this later, like more on that later. We followed a user-centric approach, as I said, putting the consumer at the center, trying to engage with them and see what are their preferences. This was done to inform the technical development of the solution, as well as the business aspect too. And obviously the regulatory dimension. Moving on, I don't want to spend too much time here, just a quick introduction of what Sender is. There's the technical solutions as well. But let's take a step back and kind of consider in general what is demand response and what is the business relevance of demand response. So as some of you may already know, that we need energy flexibility. In general, we need our grid to be more flexible because we want to achieve our European policies for energy transition, for decarbonization, for being a carbon neutral as like a society, and in doing so, we are reliant on this non-programmable or this renewable energy that we cannot control. So we kind of have to take it as it is on the supply side, as opposed with the old way of doing of generating energy, when you could control how much fuel, gray energy or non-renewable energy that you're using. So we're looking at the demand side. How does this get translated for the user is usually you have to invest more in flexibility, which is translated to higher prices. as well as in certain times the energy as a commodity is more scarce. And this presents a business opportunity because as the growing need for flexibility is happening, this opens the door for solution developers in the smart home and in IoT when we're looking at the residential sector. And here I want to make the distinction between implicit and explicit demand response. So implicit is one where you use it's not direct. You're not asking people to change their behavior to be more flexible, but instead you are giving them a price signal. So the price is moving, is variable, is dynamic. And this is already implemented in a lot of the member states in some region. I'll talk about this very soon. And then you have the explicit one, which is you are going to send a direct request, or you already have control over some assets on the demand side, and you change it to try to balance the supply and demand. So having gotten this out of the way, I want to talk a little bit about some regional trends in Europe. First, for implicit demand response, this one that is related to having variable pricing. So the electricity is not fixed, but rather it's changing to reflect the supply and demand. For this, when we looked at the market, we found out two things. First, there is a growing need for availability of smart meters, because that is what enables demand response, what enables you to have measurements every hour, and enables you to have like bi-directional communication. And the other side is the regulatory aspect, which again will be discussed a little bit more by my colleague Michael. And it is the regulations that enable this. In some countries, they are currently undergoing the transition. Some other countries, they are already quite advanced. They have smart meters already in place, and they have a lot of their users already on these dynamic pricing or hourly pricing. And if you look here, the first region is in the north, in the Nordics and the Baltic region. They already have pretty much 100% smart meter rollout. And then when you go to the next one, Western Mediterranean Europe, they have. It depends. They are not at 100%, but there's a lot of government support. They're pushing for this. They're trying to implement it, both deploying the smart meters and then in turn preparing the regulations and their tariff system to accept this dynamic pricing. Central Europe, Germany, Belgium, they are a bit lagging behind when it comes to the smart meter rollout. And then you have Eastern and Southeastern Europe, where they are kind of not on the map yet. They're very slow on the uptake. So these are kind of the four main trends that we see right now in Europe. There are some exceptions, and there are some unique things about each region. But just the general idea is the more advanced, the more like the older you've had already deployed smart meters and have the dynamic pricing regulations in place, the more you have the population aware of this. There is probably also some businesses already capitalizing on this. The disadvantage is that these populations are kind of small in number. The market size is not that big compared to the other regions. But you also have some advantages, like you have tech-friendly populations, the economy is more developed. And we already have one pilot in Finland in this region, in the first Nordic and Baltic region. So we have also some real experience with this. If you look at the second one, there, as I said, maybe the customer base or the consumers are not as educated, and they have a lot of preference on resisting change. But there's a lot of potential there because it is like things are moving very quickly, and it is a larger market. And then when you look at Germany, Belgium, Switzerland, Central Europe, they are also very strong economies. The regulatory changes are happening very slowly. So there are already some businesses working there, and they are trying to find innovative solutions to capitalize on this when it comes to implicit demand response, or prepare the user base for this once it's a go. When you look at Eastern and Southeastern Europe, it's kind of a very long project if you ever willing to do a business there. It's a very long-term thing. You're kind of doing the long game. Explicit demand response. So we're looking at, for the residential sector, this is only available through an aggregator or a virtual power plant. So basically an entity that is kind of acting as the middleman between the energy market and the residential users. And there's a lot of aggregators also available right now and virtual power plants. Usually they focus on specific assets if they're looking at residential, but most of them focus more on industrial as the potential for flexibility is higher because the demand and the consumption is much higher. And instead of kilowatt hours, the energy, it's more like in the range of megawatt hours. So that's what they're looking for. And the trend is very similar. Also related, there's a correlation between the smart meter rollout, maybe not as much as implicit, but it's still happening, and you see pretty much the same pattern. This is a very quick summary, and if you look here, I put 3 markers. We have already a pilot in Spain, so a little bit on the Western Mediterranean region, where it's a lot of government support, a lot of progress. We have also a pilot in Austria, very similar situation, and in Finland. So we have some experience working with these 2 things. We don't have with Central Europe, but Austria is very close. It's kind of didn't make the cut because they have almost 95% smart meter rollout, even if the uptake on dynamic or real-time pricing is not catching up as fast. So that was part where kind of looking at the market, looking at what enables demand response to be commercialized. So now I'm just gonna kind of shift perspective to how we went on about the business model implementation. There was the overall approach, and here, this was we tried to structure it in a way that makes sense. This was done for our replication booklet of the project, should be available soon on the project website. So if you're interested, you can check that. It has a lot more than business model. Just wanted to make a reference to this. And it starts with, it has 7 steps. The first one, I already started talking about it. It's focused on the market, trying to kind of find what kind of criteria, understand the market, and understand what kind of business you could conduct. So looking more at the potential. The second step, focusing on what we call success stories. So we are looking at instead of looking at the landscape, we're looking at businesses that are already working, are already commercial in the market and already offering services and products. And the goal of this is to kind of create some sort of a data set with the company names, information, business model information. And after that, you can identify some patterns and trends. And once you have this, you can have some preliminary business model directions that you can consider once you kind of also integrate the project, the specific project implications. If you move to the right-hand side, so far it has been linear, kind of every step depends on the one before. But if you look on the other side, it's iterative. You cannot really put it in a linear way because you can start anywhere. You can also start from really early, which is from steps 5 to 7. It focuses on feedback. So we're trying to get these directions and refine it, find some specific things, maybe do another check with the regulations, check with the partners in the project, check what kind of preferences they have, what kind of experience, check with the demonstration sites. So you're trying to kind of do some sort of a feasibility check. And ideally, you would also want to quantify what kind of revenues you can expect. Anyway, this was the general approach, and now I'm gonna walk you a little bit through what was done in the Sender project. Hopefully that would inspire you to do something similar. So this was the market identification or success stories one. I mean, here we just use very simple Excel sheet, just the company name, which geography they're active in. And we, like, in order to streamline the identification of their business model information, we used the business model canvas, which have this like 9 building blocks. You look at what is their unique value proposition, what kind of customers they are serving, what assets they have, their partners, all of this very relevant. And once you've done this, as I said, step 3 was to kind of categorize it. This is one way that we've used to categorize this. If you look at the y-axis, we try to see what kind of demand response they are offering. Low means almost none or implicit. High means explicit, where they are, have aggregation already in place. On the y-axis, you have kind of the service portfolio. Are they focusing on some specific assets, or are they serving smart home convenience as kind of the focus of Sender? From that, we identified 6, let's say 6 + 1, 7 patterns. The first one is this one-stop shop marketplace. Usually they are selling their own technology, but they can also sell other that is compatible with theirs. There are some examples of this there. You can check it if you'd like. There's also energy retailers. These are people that are they are selling. They are like the provider that you make the contract with to get your electricity at home. In a liberalized market, it is separate from the operator, so they are acting separately. Some of them have they are capitalizing on the customer base that they have, so they are offering some services to use the implicit demand response, or also it could also be explicit. And they, as I said, they are already the retailers. They have the customer base, and then they find this a good chance to offer more services. Then you have the aggregators. These are their sole business model is just to aggregate energy flexibility and then sell it as explicit demand response. Usually not so much from residential, very few examples. If that is their only offering. And then you have the software as a service. This is relevant for the Sender project because we have some tools that were developed in the project that work more in a business to business case rather than going directly to the customers. No, you try to collaborate with someone else to license or to use your software or platform. And then you have two interesting cases here, or patterns, the smart asset specific solution. These focus on very specific asset. They specialize in it. They try to give the best solutions when it comes to it. Just to kind of give an example, the Thermovolt, they focus on heating solutions. So they have pretty much everything. That's their sole focus, and they offer the best. Then you have the customer focus. So you're, instead of focusing on what assets you have the other direction of, okay, what is the customer needs? And you try to cater to that and give them like a full comprehensive solution. In this case, there's, for example, a company like CleanWatts, which is targeting, I think, multi-location businesses. So you're looking at hotels that have more than one place, or a very kind of widespread facility. I think they also have some projects with airports. I don't remember which country, but it's either Spain or Portugal. And then you have the last one. I really struggled to these are the ones that are quite unique. They have more than one unique value proposition. For example, Ingenic, it's a company from Sweden. They started as doing like smart control for heating systems, but then they kind of expanded. They're also act as aggregators. They also do some customer specific solutions. So they have so many things happening, and also one-stop shop marketplace. So it's kind of difficult to put them in one category. So we kind of decided, okay, let's put them in a separate way. Okay, this was a lot of information. Step 4, which is to try to position the Sender solution or your own project. And try to see why it's different. So looking at the technical solutions, looking at what offering it is for Sender, for example, it was something that we were trying to build it for the user since day one. We're trying to engage with them. We want to ensure that it's still convenient for them. They're very, like, they retain their comfort, their control over the assets. There's also the aspect of interoperability where you have a central platform and it is API driven in a way that you can connect any technology from a different provider to it. And I would say also there is the engagement plan. We have worked extensively in trying to engage the customers and retain them to like in our demonstration sites. And we've worked also with other projects on that to have kind of a combined shared learning thing. And some of these are available on the website. This is kind of the competitive positioning. So looking more at what sets Sender apart. Most of this I've already covered. So I will move on. And this is kind of a schematic that shows what we think Sender's best positioning and what best business model direction is at. Well, it's supposed to be modular. It considers the preferences of each partner. So if you look at the right-hand side, this one-stop shop for smart home solutions, it kind of centered around the Sender box or hub, which it connects everything together, and it also can be linked to user interface application where the user can monitor and control their assets. And then on the other, like the left-hand side, you have asset specific because we have some partners working with heating, with the heat pump, and to try to extract flexibility from the using the building as a battery. You have also the hot water tank, which also has showed some really good results for our demonstration, considering how much flexibility they can offer. You have also the EV charging solutions. And there was also the community peer-to-peer trading, which was not done in the demonstration because of regulatory barriers, but it's very good. It was also it's very well advanced. So this layout, the goal here is to make it possible for the partners to have plans to exploit their solutions either individually, or they can find synergies amongst each other to go and try to validate this business model and maybe go and create a legal entity and enter the market. One final thing I want to mention here, that's I think my last slide, which is that the idea here is to try to make something that is future-proof. What does that mean? You are trying to kind of anticipate how the market is being shaped, because this project was started in 2019. The energy market and the landscape was different back then, and a lot has happened, and we have learned a lot throughout the project, weaknesses and strengths and weaknesses, and we're trying to learn from both of them. So there's a lot of learnings here, and this is kind of the result of the business exploitation plans that we have in place. So that was all. I think if you have any questions, I think there was a lot of activity in the chat, but I wasn't able to read it. Stibelis, are there any questions?
Hello.
Hi.
Yeah, maybe we have a question from Aswan. Nice. Okay. About the use cases. If we have drafted pre-standard for use case definitions, integrated demand response, energy flexibility, energy storage for district level smart energy grids. I just answered that we follow the template IEC 62559. So I can send you the link, or you probably see it's also in the website of Sender to download the deliverable 2.4, which is the use cases definition. We have here the 5 use cases because we have worked with Aswan, working on other projects in Triala. Yeah, know him well. And yes, they are described with UML diagrams. Yes. So maybe we can okay.
Yeah,
do you
I want to add
something?
something. Yeah, the business use, like the use cases, was also a result of a co-creation activities. There was surveys, there were workshops. I mean, they were during COVID, so they were online, but there was still some engagement with the demonstration sites before they were built. So they were not kind of done separately, but they tried to find the preferences of the users as well. So this was taken into consideration.
Okay. Well, I don't know if do you have more questions, aclarations, clarifications you need to ask, or another ones? Do you have more questions from this part also, business models? Okay, so now it's everything so clear.
Well, if you have questions, also feel free to
Yeah, of
contact
course.
me.
I mean, you put in the chat.
Yeah.
I will try to answer, and then we arrive the Q&A as slot prepared. Then we can discuss more about it. Okay.
All right.
Just to not interrupt the explanation of this. I think that Ashmore is right, and so just with a few seconds and
Yeah.
define KPIs for greenhouse gas emissions.
Yeah, I can take that. I think it wasn't a specific KPI in the project because the focus was on demand response and the use cases. They already
Flexibility.
already have some energy efficiency like KPIs. It has renewable energy generation, but it wasn't directly measured the greenhouse gas emissions.
Yeah, directly, I would say no. Maybe I can check in the deliverable because maybe something about green measurement of KPIs, not exactly this, but I can check to be sure if something similar has been defined. Because the latest results on KPIs will be right now delivered by the end of this month, but they will be public once the project is officially closed by the commission. So not right now for the whole public, but I can check this. Okay, in the deliverable for you.
Yeah.
Any other question right now? Okay, so maybe I can let the floor to Michael.
Yeah, I will. Okay. Yeah, you can take over, Michael, the presentation.
Yeah, you can click on controller and then.
Okay, so I'll try. Thank you very much. I think it should work. Mm-hmm. Yes, it does. So very welcome everybody, and also hello from Austria. I'm going to present to you some aspects as a part of the regulatory work package that was done by our institution in terms of the regulatory aspects and the also ramifications in terms of suggestions how to overcome these. Basically, the first part was first and foremost done in Work Package 4, in particular Task 4.3 by a colleague of mine, Professor Willi Süssenbacher, who has also in-depth analyzed the regulatory frameworks such as to overcome physical barriers and also to overcome regulatory and judicial barriers. And in particular in deliverable 8.1, as part of Work Package 8, we analyzed the barriers to integrating demand response as a general field. We defined those. There was a policy and regulatory analysis in terms of how to enable demand response as a key future technology for smart energy systems, and also the potentials were identified. So the main focus, while we did an analysis on the entirety, was nevertheless given to the 3 countries of the testing and demonstration facilities. Good. Primary targets, as just as a quick introduction of demand response, is the adjustment of energy consumption in general based on grid conditions. So we try to do something supportive of a fairly stable utilization of grid infrastructure and capacities. It's also meant to assist in balancing supply and demand efficiently. As we heard before from Ahmed and also Estibaliz, we need some technology in order to monitor the exact state of both individual consumers and also, of course, the grid as a whole. Historically, this was a unilateral say, direction or dimension that was used in terms of consumption. So from central points of generation and production via transmission and then distribution grid to a certain consumer group, whether it's residential or commercial, and a consumption in these, say, decentralized places. In the future, and already now, we see a much more bidirectional flow of energy capacities, and also energy as a electrical energy as a power and energy dimension. And that is one of the big kind of reasons for demand response to be promoted so intensively, because we need to get also renewables from decentral production sites to the grid, but also maintain our grid infrastructure in a sense that it's used in a fairly stable way. So basically, the reduction of costs of this integration of renewable energies and energy capacities is one of the main goals also for demand response, primary targets. We also identified 3 auxiliary targets of demand response mechanisms. That is the support of grid stability and blackout prevention, a topic that is, in public media also every other year or so. Of course, there is a technical dimension behind this, so we need to be aware of the consequences and also the ramifications thereof. So one of the goals to enhance demand response is also to support the grid stability. Another auxiliary goal, and this goes back to the question asked before in terms of KPIs for greenhouse gas emissions, is we aim at reducing the use of fossil fuels in power generation per se, amongst others by increasing renewable energy integration to the systems. That also requires some smartness and also some demand response capabilities and mechanisms. And thirdly, that prosumption, of a case where a prosumer, meaning a consumer and a producer of energy, is integrated into the grid more intensively, we need their participation from residential consumers, but also from other kinds of consumers. And in order to doing so, we need demand response mechanisms. We, in a very, very brief overview, we aimed at showing you the, sorry, that was one too quick. Tried to enlarge it. We aim at defining and classifying demand response programs. Basically, we have, say, 2 main streams. The first one being price-based, i.e. implicit demand response mechanism. That is, a customer chooses a certain kind of a time-varying tariff, which could include energy prices and grid tariffs, or include one or the other. In the most frequent cases, it's only energy prices that are implicit and therefore can be classified as price-based. So basically, the aim of these implicit demand response schemes is the reflection of the value of costs of electricity and transportation in different time periods, which goes into this discussion we had before, also in terms of how to utilize a certain static grid infrastructure in a more dynamic way. We have a calculated theoretical potential for this implicit demand response in various EU countries, with, of course, particularly relevant countries being identified in France, Italy, and also Spain, as well as the UK, which is not a part of the European Union per se, but was historically, before 2016, also analyzed in that regard. And the theoretical potential is not only given by a country's size, but also by the shapes and structuring of its energy grid in detail. The second big family of demand response schemes that we have is incentive-based, meaning consumers in one way or the other receive direct payments. That is basically something, if we follow the definition, if we follow the definition, it is the aim of explicit demand response that the aggregated demand side of resources are traded in the wholesale, balancing, and auxiliary service and capacity mechanisms. We'll come to a short explanation in detail of what it means. I just wanted to highlight the potentials that have also been analyzed in this this graph, as you see here, with the biggest potential being manifested in this country of Italy, followed by Spain and the UK as well. So basically, the idea is here to engage with the customers on the inside of the demand response application, meaning the final customer, in a sense that we can provide auxiliary services to the grid, such as services to stabilization and others. The next big aspects of our analysis was the analysis of barriers to introducing demand response schemes in particular. And there is a methodological overview, just very quick overview in terms of how this was done, amongst others, by means of a pestle analysis, meaning that we were able to derive the kind of statements and main gist, the main kind of findings from a policy recommendation framework. Meaning also that we would take into consideration the main barriers, but this can also be and only be done in an ex ante way, which can also project the effects of, say, overcoming these barriers. I will come to the recommendations and how to overcome these in a second. The main barriers identified to demand response in the European Union was basically a, kind of assembly of 5 individual barriers. Those are regulatory and policy barriers, economic barriers, social barriers, technical, as well as environmental barriers. I will briefly discuss those 5 and try to stay on time, also to allow for interaction and, of course, questions. Starting with the first and most prominent one being the regulatory and policy barrier dimension definition. Basically, one of the main and key barriers identified in terms of hindering the implementation of demand response was a set of inconsistent regulation across regions. We find a physically more interconnected power grid than a regulatory interconnected power grid, despite the substantial efforts also by the European Commission and ACER as the European regulatory agency to solidify and also consolidate these different regulatory regimes. We also find a lack of political support and institutional resistance to that, and also, or as a consequence by all of these, a lack and a limited level of harmonization and at national levels, regulatory, say, implementation practices, and also on the EU level. Secondly, the economic barriers. The economic barriers have been identified as a second. There's not a ranking. I would like to stress that, even though there is some, say, more prominent and more well-known barriers, but the economic barriers have, in a very, very early stage, been found to be particularly detrimental to the implementation of demand response. In particular, the high investment costs for demand response technologies. There were several countries, historically several countries, that have approached this issue in a very, very different manner. If you think about the more, say, industry oriented, say, load shift and also load shedding practices in certain European countries, amongst others France, with a very big country and very stable production capacity, and others that have relied on others, such as, for instance, the German-speaking countries in a more prominent way, where residential customers, in particularly in off-peak time periods, were incentivized to increase their production, therefore also reducing their production in peak periods. So these smart demand response technologies are high in investment, and therefore these costs pose a very, very substantial economic barrier. We also have an unclear set of financial benefits for consumers and businesses, and a lack of incentives for market participation, which we will see later on will be especially relevant in the future. If we don't have a market signal corresponding to the true opportunities of that action, we will not see any further progress in terms of, say, integrated demand response in the daily business of our energy production, transportation, distribution, and consumption effectively. The 3 following barriers are social barriers, technological, and environmental barriers. Just on a brief note, trying to stay on time, we have very low public awareness and acceptance of demand response and its importance for the energy transition towards renewable, for the reduction of the carbon and greenhouse gas emission effects of our power production in particular, and that is something that needs to be overcome. We also have a very big issue in terms of data privacy and cybersecurity. The more data you share, of course, on production and also of consumption patterns, the more vulnerable people are in terms of other privacy rights, such as residential customers, whether they're at home or not. This is something that can be elicited out of a appropriate analysis of the data on consumption patterns in particularly. We also have a uncertainty about long-term economic effects, which hinders the implementation of user-centered demand response initiatives. We have a parallel project that I'm actually leading in Austria, where we developed a web platform that basically distributes information on high and low peak periods, also on own production. It has an optimization algorithm built within that's based on your historic consumption patterns, gives you recommendation when and which loads to actually activate. But the problem is, we see a very, very strong deterioration of interest after the first 2 to 3 months. Basically, we see a very intensive period of 4 or 5 weeks, and then we see this unfortunately very sharp decline in interest, and therefore also in the use of these tools. In terms of technical barriers, we have a lack of standardization and interoperability. We have several challenges, including the IoT, Internet of Things, artificial intelligence, and smart metering technology that was already mentioned by Ahmed. So thank you for the pre-work done on this, which, especially the later smart metering, is a key prerequisite in order to come to a more to better state of knowledge in terms of consumption patterns. And of course, we have high security and infrastructure demand, both security risks and infrastructure demands. In terms of environmental barriers, just briefly, we have limited space for new infrastructure. We find ourselves in a very densely populated area. If you compare it globally, we as a European society, in a greater sense, need to address this. We also have a certain competition with other renewable technologies when especially it comes to grid extensions, if that is, say, the alternative route. So we need to be we need to take very much care of this in order to also address the future demand patterns, how to integrate them into the networks that we have. And finally, the sustainability concerns in production and disposal, especially in terms of the production patterns, needs to be addressed. In terms of time, I'll move on and hopefully, this was too much. Yes, so just one. We identified a list of strategies to overcome these identified barriers. Basically, the combination of organizational, technical, and political policy strategies is recommended. In particular, the regulatory support through harmonized policies and financial incentives. Also, the technology integration with smart grids and the technologies mentioned before, such as, of course, IoT, blockchain technology, and others. We need a much stronger stakeholder collaboration between the industries, regulatory agencies, and consumers, and the greater public awareness in terms of campaigns and financial incentives to boost these forms of participation. In terms of the successful demand response implementations, we also have a best practice, outlook that is taking into account the United States, where we have certain positive, schemes that were found to substantially reduce peak demands. We have some, first signs in the European Union also that we see a stronger demand side flexibility in more and smarter grids. And we have in Asia particular demand response solutions integrated in integrating renewable energy. That is, there is a bidirectional dependency of both smart grids or demand response inclusion and renewable energy, enforced renewable energy integration to the grids. So basically, some of the lessons learned throughout, especially D81, where that clear regulations and incentives drive participation, technology integration improves the efficiency and the scalability of the solutions, and customer engagement is crucial for its success. Looking on time, I'm very trying to do this very quick unless I get other recommendations from Estevaliz. No, I think we still have time. So basically, we find in terms of the trends a certain set of emerging innovations that are have a strong demand in terms of AI-driven predictive energy management, and also in terms of the blockchain for secure energy transactions that are needed for these purposes in particularly. We also have a short overview of the impact of future trends that is a more decentralized and flexible energy grid needs also a greater role of consumers in energy management in particular. So I believe I'm close to the end. I will skip this one because I believe I'm already a couple minutes over time. Is this correct, Estevaliz? Can I cut it brief?
It's okay. You can. You have time. You have.
I have time. Okay.
Yeah. Yes.
Okay. Thank you. Thank you for checking. So basically,
you can explain calmly.
Yes. Okay. I will try. I will try and still keep my timeline on track. So basically, what some of the roles that we have identified is particularly in terms of policy coordination and also rollout of coordinated policies. That means the government's regulatory agencies have a strong and very imminent role in the demand response implementation. These policy, bodies from national regulatory agencies through the European Agency of Energy Regulators, through also the national legislative in terms of power per se, has to ensure fair market access and consumer protection. That is key in order to overcoming especially the social and economic barriers. If we don't ensure that this will be not driven towards the success that is envisioned. And also the coordination between the main bodies that are three that were identified, that is utilities as a former term of an integrated utility company, meaning the now bundle of production, transmission, distribution, and also final energy sales companies needs to be thought with regulatory bodies and also with the consumers. So basically, the benefits that are prevalent in demand response for the four kind of categories that were analyzed: prosumers, reliability, market effects, and environment, can be disintegrated in the subset of these benefits that are seen here, from grid stability towards diversification of resources, from capacity increases of the grid to the reduction of the carbon footprint of energy provision and consumption. Yeah, already coming closer to the Q&A session that we hopefully will have afterwards. We analyzed that the main goal for the future is to enhance the demand response implementation. We have here a set of 2017, 2018 set of countries that have particularly moved ahead in this regard, meaning that these demand response schemes have been particularly promoted in France, of course, Belgium, Ireland, and Finland, while others have to catch up. That is also, I think, very well documented by the set of demonstration sites where we have different kind of levels already of implementation, but also from a theoretical base, this has been documented enough, and initiatives such as the one in Sender those are very important to drive these kind of public awareness for this consolidation in the future. Okay, so coming towards a conclusion, also as part of this small but important aspect of the work done, is that the effects of demand response implementation, or stronger demand response implementation, on the energy system efficiency are significant. The impacts in terms of economic, environmental, and technical benefits. So if we had to kind of close this chapter by a certain statement, we would choose the following. That is that we identify demand response to being the key of the future sustainable energy system provision and consumption. That the success of it depends on the technological innovation, the supportive policies, the economic incentives, as well as an active consumer participation. That was it, and I thank you very much. I would very much like to take some questions. Mr. Wallis.
Yes, okay, well, there was some activity in the chat about the use cases and so on. I don't know if there is a question. Do you need more clarification about the subject already discussed within in the chat? Or is there any other question about regulatory and market recommendations? So we're clear. It's okay. Well, I will continue maybe with the closing remarks. I will try to take the control. Yeah. Just a few conclusions about the energy regulatory analysis. There were found more than were found identified, we can say, where more than 40 European energy policy goals. Most of them are addressed in the regulation. Not all these aspects of them, but when you go, when you arrive to the national regulation, the transposition sometimes is still missing. And other times it's something in between. It's not completely or fully implemented, but something similar, we can say. So these are the regulatory barriers that we have had during the project to assess, to do the assessment in the pilots and to really deploy everything that we wanted with the use cases defined. Just I would like to show you this picture because, well, this picture, this table, because it is really very clear. As you can see, here are 5 use cases that have already written in the chat. Residents' explicit demand response, maximization of the use of renewable energy sources, minimization of electricity bill, remote monitoring and control of use of household devices, and peer-to-peer trading. As you can see, this is like the red light, the traffic jam, okay, the traffic light, sorry. We have green, yellow, and red, which is clear what they mean, I would say. And you can see that, for example, in 2 countries, we didn't demonstrate some use cases because it was not possible by the regulation. It was not transposed yet, or not in the with all the aspects that we needed to demonstrate these use cases. And in another ones, we are like in between. So I think this is very representative. This is what I really wanted, you know, to show this a bit. Okay. And just some key conclusions from the business model development about the modular architecture, flexible platform for smart energy and home device management, forecasting and digital twin. Okay, we have the intelligent tools for predictive control and real-time simulation, interoperability, which is really very important. Sometimes we already have issues with some kind of interoperability, and if you have integration with different systems, it comes. Also for security and privacy, but mainly for security. Seamless integration with diverse systems and devices. User empowerment, which is the control is intuitive and enable to energy autonomy and flexibility. And using a market-driven design, core feature, co-created with feedback from the users, but also from the stakeholders of the sector, because in the co-creation steering group, we really had not only end users and partners from our consortium and center, but also different DSOs and actors from the energy sector, which were really important to us. I will not go maybe too much into detail about here the different aspects specific of the business model, but just I would like just to remark these 5 main points. of them. Just for concluding a bit. I don't know if you have any general question or so, and about what we have already talked today, or maybe from the other webinars, generally speaking, from the project that you would like to know, or more information about us. You can see in the website of Sender project most of the information that we already have. And when the project finish, that is going to finish this month and officially, so we will provide the latest results of deliverables and outcomes in the following months when they are ready to be published. So that's all by my side. I don't know if another ones from the project coordinating want to say something, because today we finished the final CITES webinars. Okay, of Sender. So many thanks to all of you that have participated in the webinars as public participants and also from the project. Okay, as you can see in the chat, Manel has written this. Maybe I can give you the floor if you want to say something while you're right there.
Yeah, thank you, Estibaliz. Just to let you know that this webinar and the other previous one will be available on Sender YouTube channel, so you can see them or rewatch a webinar if you have further more question in the following weeks.
Okay, many thanks for the information. Yeah, okay, and thanks okay for the participation. Okay. Okay, so that's all by my side, and if there's no other question, okay, we will get in touch as well with Antonio about this this report of IoT. Okay, this topic. And well, thank you, and have a nice day.
Have a
Thank
nice
you, everybody.
day.
Bye bye. Thank you.